Welcome back, everybody. Today in lesson 1-3, we're talking about angles. And we'll actually spend a few lessons going through angles and their properties. Okay, angles are important because they're going to be another one of our building blocks that kind of all our geometric figures throughout the year are made up of. So today what we'll do is we'll define angles for you. We'll talk about how to name them and then also get into measuring angles. Objective today to find and compare the measures of angles. Here we go. All right, so first off, what is an angle? I'm going to say an angle is formed by two rays with the same endpoint. So if we take a look at my picture of an angle here, I can think of it as made up of two rays, rays AB and AC. Okay, two rays that share an endpoint. We'll say the rays are the side of the angle, and the endpoint where they meet up at is the vertex of the angle. Okay, vertex will be a word that we use a lot through the semester. Basically, anytime two lines come together to form a point, as in a triangle, we have a vertex. And I've got a bunch of different letters and numbers on here. There's going to be a few ways we can name angles. And as we go through, we'll see advantages and disadvantages to each. The first is with just the vertex. So the vertex of this angle here is A, so I can call this just angle A. This little symbol that looks like an angle is the angle symbol. Okay, so probably the simplest way we can name this is just angle A. All right, now I can also name an angle with 3 points with a point on each ray and then the vertex. So I could call this angle BAC or angle CAB. Now notice both times I said that, I kind of traced through the angle. We could say BAC or CAB. I can't skip across my rays here. I can't say BCA or CBA. I've got to keep that vertex in the middle. I've got to essentially trace along that angle as I name it. All right, last way then is just with a number. So sometimes I'll throw a number on the interior of the angle. So I could call this, in this case, just angle 1. And the reason I'd want to do that is if I don't care about the specific points, I just want to talk about angles. Okay, I'll throw a number on it. Kind of like we do with lines when we just throw a lowercase letter on it when we're not worried about the specific points. All right, let's go ahead and practice naming some angles here. So in problem 1, I have a geometric figure made up of a few different angles. Part A says, what are two other names for angle 1? All right, well, angle 1 is on the interior between rays MJ and MK. So we'll say angle 1 is what you see in blue here. And how else can I name that? Well, I can name it with 3 points. I could call this angle JMK. All right, or I could flip that order around. I could say angle KMJ. Right now with this one, something I can't do, I don't want to say just angle M with just the vertex. And the reason for that is when I say angle M, I'm not sure which angle you're talking about. We could be talking about angle 1, angle 2, or the two of them combined. Okay, in general, the only time we're going to use the vertex by itself for an angle is when that's the only angle at that vertex. If there's multiple angles there, you don't want to do that. All right, that's part A. Part B's up as well. Why don't you take a minute, pause the video, get some answers for part B, and then you can hit play to check your answer. Okay, we want to give you a chance to think about these instead of just me showing the answers to you. All right, so running through B quick, we have angle KML. Well, I suppose the first way we could rename that without even looking at the pictures, we could just flip the order of the letters. We could just say angle LMK. Okay, so KML is here, and if we go in the opposite direction, we get LMK. And now with this one, the other way we can name it is using the number on the interior. We could also call this angle 2. Okay, so there's two different ways to talk about that same angle, KML. The next thing we're going to talk about is measuring angles. Just like we want to be able to measure the length of a segment, we also want to be able to come up with numbers to give a measurement to our angles we're looking at. We'll say that the measure of an angle is a number that describes the relationship between the directions of the rays that make up the angle. So what we're looking to do here is come up with a number that shows that this kind of smaller angle here, the rays are relatively pointing in the same direction, whereas with this bigger angle, we'll give a bigger number to because the angles are kind of more in different directions there. Okay, that number we'll use is degrees. We'll measure things in terms of degrees. Now, just like I could measure a length in terms of feet or inches or miles, we'll also have different ways of measuring angles. We're just going to use degrees in this course, but as you go further in math, you'll see different ways to do that. Okay, so we have our degree measures, and then based on that degree measure, we'll classify our angles into one of four categories. We'll say an acute angle is an angle between 0 degrees and 90 degrees. We'll say a right angle is an angle that measures exactly 90. Okay, so we get this square angle here, and we'll show that it's a right angle by filling in this extra box. Okay, we'll say an obtuse angle is somewhere between 90 and 180. Okay, so if it's greater than a right angle, but it's less than a straight line, we'll say it's obtuse. And then if that angle forms a straight line, if the angle measures exactly 180, we'll call it a straight angle. All right, so let's practice measuring and classifying angles. Now I have an example of a protractor here. We're really not going to pull the protractors out at all this semester. Okay, but let's kind of review how they work. So we want to measure three angles here and also classify their type. Let's start off with angle LKN. Now if I'm talking about the degree measure of an angle, I'm not going to say that angle LKN equals something. I'm going to say the measure, so M first, of angle LKN is equal to a number. Okay, if we trace that out, LKN, this one's going to be fairly easy to figure out the measure of. Okay, since one of my rays is along the 0, I can just open myself up and count up until I get to where that angle hits. And with this one, I'm going to use the 145, the bigger number, okay, because our angle is greater than a right angle. So we'll say this angle measures 145 degrees. Okay, 145 is greater than 90 but less than 180, so that's why we'll say this is an obtuse angle. All right, next up, let's find the measure of angle JKN. All right, let's connect the dots, J, K, and N. All right, looks pretty easy. Looks like this one's just a right angle. If I follow my angle up to where it hits that second line, it's right at 90. So we'll say it's equal to 90 degrees, and that is a right angle. All right, then for the last one, this will be kind of the tricky one and get us thinking about some other stuff we're going to do in this lesson. We want the measure of angle JKL. Let's show you why that's tricky. If I connect my dots, J to K to L here, I end up with this angle in green. Now this one will be a little more difficult because I don't have either of these rays along the 0. Here's what I can do instead though. I can look at the larger angle, HKJ. I know that HKJ is a right angle. So what I can do then is I can take 90 degrees for that right angle and then subtract this smaller angle here, the 35 degrees. Okay, which is going to leave me with the rest of that right angle. 90 minus 35 would be 55 degrees. All right, so know that the measure of angle JKL is 55 there. Okay, because 35 plus 55 would give me that 90, would give me that right angle. Okay, so a little problem solving with our angle there. Classifying then that is less than 90, so we know it's acute. Okay, again, not going to do really anything with protractors this semester, but that's a little review of how you would measure angles by hand if you needed to. We're going to talk about two more concepts dealing with angles today. And the first is the idea of congruent angles. We'll say that congruent angles are angles with the same measure. Now, just like I won't say that two segments are equal, I'll say if their lengths are equal, the segments are congruent. Same thing here. I'm never going to say that two angles are equal. Angles are geometric objects with several different properties to them, such as measure, position, points they have on them. We'll say that the measures are equal, and if the measures are equal, we'll say that the angles are congruent. So in this case, we'll say that angle A is congruent to angle B, where the congruent symbol is the equal sign with that squiggly line on top. So if they have the same measure, the angles are congruent to each other. And then the way we'll show they're congruent is if they have an equal number of arches drawn on the angles. That's how we'll communicate, or that's how we'll read the angles are congruent if we don't know the specific measures to them. So let's go ahead and practice using that congruence idea here. For problem 3, I have kind of a messy looking geometric figure. Okay, and the point of it is to kind of help you sort out through it, sort out the congruent angles. Part A says which angle is congruent to angle WBM. Well, let's see here. If I connect the dots, W, B to M, we're talking about that angle I have in blue here. And it has a single arch on it. So the angle congruent to that will be the other angle of the single arch. I see a single arch right there. So that's going to be this angle here, YEM. Excuse my not so straight lines there. All right, or I could use some other letters. Since A is also on the ray, EY, we could also say angle AEB. Okay, or I suppose AEM or YEB. Okay, if there's ever more than one point on the ray, it doesn't matter which of those points you use. Okay, these are the same angle. All right, so that's how we can identify congruent angles here. Problem B is the same idea. I want you to take a minute, pause the video, figure out which angle is congruent to YAC, and then hit play to check your answer. All right, running through part B, angle YAC is the angle you see in red. And this angle is marked with 3 arches. So the congruent angle is going to be the other one in the figure with 3 arches, which would be angle, we could say WCJ. Or I suppose BCJ. Either of those would be correct ways to mark or to label that congruent angle. The last thing we're going to talk about in this lesson is the angle addition postulate. Remember, this word postulate just means a statement that we accept as fact, a statement that we can't prove is true, but we'll accept as true. It's kind of our mathematical common sense statements. And this postulate just says that if B is in the interior of angle AOC, so in other words, if I have the ray OB splitting the angle AOC into 2 separate angles, then the measure of angle AOB, so AOB, this kind of yellow angle on the left, plus the measure of angle BOC, the measure of the tealish angle on the right, will be equal to the measure of angle AOC, will be equal to the measure of the entire angle, the angle formed by adding these 2 angles together. All right, just like the segment addition postulate allowed us to add 2 chunks of a line together to get the whole thing, to add segments, the angle addition postulate just allows us to add the measure of angles together to form larger angles. So let's take a look at using that angle addition postulate. Now, we already used it for that last protractor problem where we had to find a part of a larger angle by subtracting the other smaller part from the whole. And here we're going to use it mixed in with some algebra. Problem 4a says if the measure of angle RQT is equal to 155, what are the measures of angle RQS, so this smaller angle on the left, and the measure of angle TQS, the smaller angle on the right? All right, so I have expressions for both of those smaller angles. And then the other thing I know is I know what the total is equal to. I know the measure of angle RQT is equal to 155. So as far as an equation for this one goes, is I can just add the two parts together and set that equal to the whole. So I can say that 4x minus 20, the first angle, RQS, plus 3x plus 14, the second angle, TQS, I can say the two of those added together are equal to the total, the 155. And then I have an equation that I can solve for x. Once I have the x, I can plug it in and find the actual angle measures. So let's go ahead and do that. With this one, we've got like terms to combine on the left side. I can add the 4x and the 3x to get a 7x. Then I can also combine the negative 20 and the 14 to get a negative 6 is equal to 155. To get the x alone then, I'm going to add 6 to both sides. That'll give me a 7x is equal to 161. And then I'll divide both sides by 7, which leaves me with x is equal to 23. All right, so there's my value of x. And then from there, I can substitute that x into these expressions for the smaller angles to get their actual measure. So I can finish off by saying the measure of angle RQS is equal to 4 times the x value we just found, which is 23, minus 20. All right, 4 times 23 is 92, minus 20 would be a 72. So that angle measures 72 degrees. Now we can do the same thing for the measure of angle TQS. That's going to be 3 times our x, 23, plus 14. 3 times 23 is 69, plus 14 is going to give me an 83. All right, so those are my two angle measures here. And just like we had with the segments, an easy way to check to make sure we did those correctly is if I add them together, 72 plus 83, I should get the 155, the total, which I do. So I know I most likely did those ones correctly. All right, that's problem 4, part A, using the angle addition postulate. There's also a part B in your note guide. Why don't you go ahead and pause the video, work through that one, and then you can hit play to check your answer. All right, let's go ahead and run through part B. In B, we're given angle DEF is a straight angle. What are the measures of angles DEC and the measure of angle CEF? Now the trick for this one is it doesn't explicitly give us the total, but I know that straight angle means an angle measuring 180 degrees. So the way I can set this one up is I can say that 11x minus 12, the first angle, plus 2x plus 10, the second angle, is equal to the total 180. From there we can combine like terms. 11x plus 2x is going to give me a 13x, and negative 12 plus 10 is going to give me a negative 2, equals 180. I can then add 2 to both sides. That'll give me that 13x is equal to 182. And then divide both sides by 13. And we end up with x equal to 14. Okay, to finish that off, we'll substitute the x value into my expressions for the angles. We can find the measure of angle DEC. That's going to be equal to 11 times the x minus 12. So we'll say 11 times the 14 minus 12. All right, which is 142 degrees. And same thing for the measure of angle CEF. That'll be 2 times x minus 10. So 2 times the 14 minus 10, which is equal to 38 degrees. And again, I can check that by adding these two together. I should get 180. For the straight angle, I do, so I know that I did things correctly. All right, that's it for lesson 1-3, measuring angles. Kind of a simple topic, but important. That's why we went through all the details. That's why we kind of took our time with it. We will be building off that. We'll be spending some more time with angles in the next lesson. Okay, so again, important subject. Make sure you get your practice done. Make sure you get through your Math Excel. Ask questions if you need help, and we'll see you folks later.